Howdy, students. Let's get it on. Now, finding the GCF, all you want to do is find what they have in common. So we look at this first one. We look at the numbers, the coefficients that lead. You want to know, what do they have in common? They both have a 2 that can divide in. They both have at least one x, and they both have two y's in their factor tree. That's it. We're just finding that GCF. Nothing else is necessary. On this one, they both have a 3. They both have at least one a, and they both have at least one b. That's all for that problem. This next one, you might think 5, but 15 actually goes into both of them. This one has an x, this one does not, so we're not going to list that as part of our GCF. This one, they both have y squareds, so we're going to pull all those y squareds out. Number 4, we have 2 that will go into both 10 and 16. We have at least one a in both terms. We have at least one b in both terms. Moving right along.
Where are we meeting again?
Cafeteria. Moving right along. We're going to take, they both have at least a 4, and they both have an x. Now when we're factoring out the GCF, we're going to also list what's left. So if I pull out that 4x, I'm going to have an x left for this term, and we're going to have a 2 left for that term. So that's the big difference. Factor the GCF, tell me what's common. Factor out the GCF, you're actually going to have to give me that entire quantity back. So this one, they both have a 3x. What's left when I pull that 3x? A 1. So if I divide 3x out of this term, everything's gone. It's a complete division. Pull the 3x out of here, and you'll be left with a 3x. That's my answer there. For number 7, they both have a 6. 6 goes into 6 and 12. They both have at least one x. They both have at least one y. What's left after I pull a 6xy out? I've got a y left from my first term, and I've got a 2. 6 into 12 is 2. I'm pulling one of those x's out, and then this y is gone. It's been pulled. For number 8, they don't have any coefficients they're going to pull, but they both share an x. And that's going to be it for this problem. All right, moving right along. We're going to take and we're going to solve for x. So on the GCF portion, you're going to look, what do they have in common? They both have a 2, they both have an x, and we'll get that parentheses going on. X plus 3 is left. When we're solving, we have two quantities, these two quantities, they multiply together to be 0. So if you have two numbers that multiply to be 0, one of them has to be 0, or more, but at least one. So I'm going to take this first quantity. If it were 0, x would be 0. Take this second quantity. If it were 0, x would be negative 3. Moving right along to number 10, they both have a 2 in common. They both have an x. 3x is left from that 6x squared, and a 2 is left from the 4. So again, 2x could be 0. That would make x 0. And 3x plus 2 could be 0. Pull the 2. 3x is negative 2. X is negative 2 over 3. All right. Moving right along. Number 11, I don't have an equals 0. If I've got a quadratic like this x squared, I want a 0 in my equation. So my very first step is to force a 0 into my equation by subtracting the 14x squared. Or the 14x to the other side. What do they have in common? They both have a 7x. Once I pull it out, I'm going to have an x minus 2. And then it looks similar to the other ones. I'm just going to grab that first one. 7x could be 0. Grab that second one. X minus 2 could be 0. And solve for x in both cases. X is equal rather to positive 2. X is equal to 0. Number 12, 3x could be 0. And x plus 1 could be 0. So x is either 0 or negative 1. All right. For factoring trinomials, this is where we throw up the x. This is where we throw up the x. You've got this process that we do. We have a times c on top. We have b on the bottom. So I need numbers that multiply to be 6, add to be 5. 2 and 3 will work for me. So I'm going to get x plus 2, x plus 3. You'll notice x times x is not 2. X squared, it's just x squared. So we've obviously forgotten to do something. This step is critical. We're going to divide by our a value. A was 2. It goes in evenly here, so I'm going to get an x plus 1. It doesn't go in evenly here. I'm going to get a 2x plus 3. And that one's all the way done. Notice no equal sign, we won't solve. If you look at number 11, there's an equal sign. We need to have x equal to something. In number 13, there is no equal sign. We won't have x equal to anything. Number 14, a times c is negative 54. b is negative 3. Remember, a is the coefficient of x squared, b is the coefficient of x, and then c is the coefficient of, well, c is just your constant value, whatever that constant value happens to be. So 54, negative 3. How about negative 9 and positive 6? That'll work. So I'll get x minus 9, x plus 6, divide by our a. Again, this is not going to do anything because we're dividing by 1, but it's good practice to always divide by a so that you're in the habit, and when you do need to, you'll execute that properly. A is 1, C is negative 25, and B, you'll notice there is no x, B is 0. Negative 5 and positive 5 will make that happen. I'll have x minus 5, x plus 5. Divide by my A value. Again, I understand that dividing by 1 doesn't do anything, but it's great practice to keep you correct throughout your process. My very last one, I've got positive 16 for A times C, negative 8. Let me write that down. So we have A times C and B, so you can see that in your process. Negative 4 and negative 4 will do just fine. X minus 4, x minus 4. Again, we'll divide by 1 to finish that problem off. Looking sharp. Moving along to that next page. I almost said moving right along again. That would have been damaging. 17, solve for x. So all of these are mixed together. No, this is all trinomials, which is fantastic. On this one, we're going to pull the x up because this is ready to go. We'll have negative 24 and negative 2. So negative 6 and positive 4 will work just fine for us. I'll get x minus 6, x plus 4 is equal to 0. But I need to remember, divide by that a value. It goes in evenly on the first one, so I'll get x minus 2. It does not, and I cannot reduce, so I'll get 3x plus 4. And now I'm going to execute the solve just like I did on the GCF portion. X minus 2 could be 0, so x could be 2. And then 3x plus 4 could be 0. X is equal to negative 4 over 3. Those are my two answers. Number 18, don't get confused and try to FOIL this out. This is already ready to go. If we look at 18 and we look at our finish step for number 17, it's already here. So all I need to do is take that 3x minus 2, set it equal to 0, 2x plus 1, set it equal to 0, and I'll get 3x equal 2, x equal 2 over 3. Remember to take those steps. You may end up messing your fraction up. 2x equal negative 1, x equal negative 1 over 2. Ready to go. Number 19, this is one of those ones where there is no b value, so it's a 0 down at the bottom. Negative 6, positive 6, x minus 6, x plus 6. Divide by that a value, which is 1. And I will get x minus 6, x plus 6. Again, it doesn't do anything, but it's always good to be in practice. So I've got x minus 6 could be 0. X plus 6 could be 0. This will give you x equal positive 6 for 1, and x equal negative 6 for your other value. Number 20, you will notice there is no 0. I'm going to make one so that I can solve my quadratic. I'll get x squared minus 7x minus 18 is equal to 0. You get negative 18, negative 7. Negative 9 and positive 2 will make that happen. So I'm going to get x minus 9, x plus 2 is equal to 0. And that'll give me x equal 9, x equal negative 2. Number 21. Now this one, we're going to throw in a couple of these just to get a little crazy. You'll notice there is no x squared. So 5x plus 5 is 0. 5x equal negative 5. X equal to negative 1. And we're finished here. And this is important that you recognize some of these. We're just going to throw in a casual no squared. All right? And make sure you're paying attention. Number 22, no 0 to start with. So I need to make sure to force one. A times C is negative 27. B is negative 6. Negative 9 and positive 3 will make that happen. So I'm going to get x minus 9, x plus 3. I'm going to divide my a out. That'll give me x minus 9, x plus 3. This is all equal to 0. So I have x minus 9 could be 0, x equal positive 9, and x plus 3 could be 0, x equal negative 3 once I pull them over. We'll cut here, box my answer, and go on to the next page.